Hello everyone, welcome back to the channel. Today, we are diving into something super important for anyone studying computer science, electronics, or even just curious about how numbers work in computers. We are talking about number system conversions, specifically converting between decimal, octal, and even fractions. If you've ever wondered how computers handle numbers, this video is for you. Let's jump right in. First up, let's tackle decimal to octal conversion. The decimal system is what we use every day. It's base 10. But in computing, the octal system, base 8, is also widely used. So, how do we convert a decimal number to octal? It's actually pretty simple. Let me walk you through it. 1. Divide the decimal number by 8. 2. Write down the remainder. It will always be between 0 and 7. 3. Take the quotient from the division and divide it by 8 again. 4. Repeat this process, recording the remainder each time until the quotient becomes 0. 5. The octal number is the sequence of remainders read from the last remainder to the first, bottom to top. Let's take an example to make this clear. Say we want to convert the decimal number 125 into octal. Here's how it works. When we divide 125 by 8, we get 15 with the remainder of 5. When we divide 15 by 8, we get 1 with the remainder of 7. Finally, when we divide 1 by 8, we get 0 with the remainder of 1. Now, if we read the remainders from bottom to top, we get 175. So, 125 in decimal is 175 in octal. Pretty neat, right? Now, what if we have a decimal number with a fractional part? For example, 40.90625. How do we convert that to octal? It's a bit different, but don't worry, I will guide you through it. For the integer part, 40, we will be using the same method as we had used in the previous problem. So, when we divide 40 by 8, we get 5 with the remainder of 0. And when we divide 5 by 8, we get 0 with the remainder of 5. Now, if we read the remainders from bottom to top, we get 50. So, 40 in decimal is 50 in octal. Now, for the fractional part, here's the step-by-step process. 1. Multiply the decimal fraction by 8. 2. Record the integer part of the result. This will be a digit between 0 and 7. 3. Take the fractional part of the result and multiply it by 8 again. 4. Repeat the process until the fractional part becomes 0 or until you reach the desired level of precision. 5. The octal fraction is the sequence of integer parts read from top to bottom. Let's apply this to 0.90625. 0.90625 multiplied by 8 equals 7.25, where the integer part equals 7 and fractional part equals 0.25. 0.25 multiplied by 8 equals 2.0, where the integer part equals 2 and fractional part equals 0.0. Now, reading the integer parts from top to bottom, we get 0.72. So, 0.90625 in decimal is 0.72 in octal. Therefore, the octal equivalent of 40.90625 is 50.72. Now, let's flip it around. What if you have an octal number and you want to convert it back to decimal? Don't worry, it's just as straightforward. Let me show you how. 1. Write down the octal number and assign each digit a position value, starting from the right. 2. Multiply each octal digit by 8 raised to the power of its position value. 3. Add up all the results from the previous step to get the decimal equivalent. Let's take the octal number 23.20 and convert it to decimal. Breaking it down, we get 2 is at position 1 and therefore we have 2 times 8 to the power 1, which is 16. 3 is at position 0, therefore we have 3 times 8 to the power 0, which is 3. 2 is at position -1, therefore we have 0 times 8 to the power -1. which is 0.25. 0 is at position -2, therefore, we have 0 times 8 to the power -2, which is 0. Add them up, we get 16 plus 3 plus 0.25 plus 0 equal 19.25. So, 23.20 in octal is 19.25 in decimal. Let's try another example to solidify this. Convert the octal number 2025.40 to decimal. Breaking it down, we have 2 is at position 3, therefore, we have 2 times 8 to the power 3, which is 1024. 0 is at position 2, therefore, we have 0 times 8 to the power 2, which is 0. 2 is at position 1, therefore, we have 2 times 8 to the power 1, which is 16. 5 is at position 0, therefore, we have 5 times 8 to the power 0, which is 5. 4 is at position -1, therefore, we have 4 times 8 to the power -1, which is 0.5. 0 is at position -2, therefore, we have 0 times 8 to the power -2, which is 0. Add them up, we get 1024 plus 0 plus 16 plus 5 plus 0.5 plus 0 equal 1045.5. So, 2025.40 in octal is 1045.5 in decimal. And that's it. Whether you're converting from decimal to octal or octal to decimal, it's all about following these simple steps. If you practice a few times, you'll get the hang of it in no time. Thanks for watching, everyone. If you found this video helpful, don't forget to give it a thumbs up and share it with anyone who might need it. And if you have any questions or want to see more content like this, drop a comment below. Until next time, happy learning.